Welcome to the lair of the Batty Boffin.
Hi there Batty fans, a little bit more higher level GCSE maths with Bathilda the Batty cat. Now today she is thinking of some numbers and they're fairly weird ones. The first one is 6.304 with those little dots above it. That's F. The second number she's thinking of, G, is 3 plus root 5. And H is quite similar, 3 minus root 5. And she is wondering whether or not they are rational or irrational. So what you need to do on here is find out whether F is rational or irrational, and we need full working and a demonstration that it actually is rational or irrational, not just yes or no on here. So a demonstration of whether F is rational or irrational, whether G minus H is rational or irrational, whether H squared is rational or irrational, and whether GH is rational or irrational. Okay, take yourself a little while, cup of tea, chocky bicky, off you go with those. Right, let's go through those bit by bit. The first one, F, is a recurring decimal, 6.304304304. Okay, hopefully you should know that all recurring decimals are in fact rational, but we need to show it. Here's how. I'm going to let X equal my number. So X is equal to 6.3043004 and so on. Now, in order to show that it is rational, I need to show that it's the ratio of two numbers. It's something over something. Now, if it were just 6.304, that would be dead easy. I'd do 6,304 over 1,000. That's a ratio of two numbers. Cancel it down if you want to, I suppose, but it's rational. Trouble is, because it goes on and on forever, I can't put that over any number. I need to make sure that it's not this going on forever number. Here's the sneaky trick. I'm going to multiply it by 1,000. So 1,000 of my number is equal to 6,304.304,304 and on forever. You see why I multiplied it by 1,000 there? Because it's 3 places of recurrence, so I move it up by 3 places. So when I do that subtraction, I get 0, subtract, on here I get 999 x's is equal to, no, all of those are noughts. 4 take away 6, can't do it, swipe 1 from there, can't do it, swipe 1 from there, becomes a 2, that becomes a 10, swipe 1 from there, that's a 9, that becomes a 14. 14 take away 6 is 8, and that's a 9, and that's 2, and that's a 6. So, x is equal to 6298 over 999. That's a ratio of two numbers, therefore it is rational. If you haven't seen this done before, check out one of the other Batty Boffin videos where I'll go through it rather more slowly. So that is the proof that F up there is definitely rational because it is a ratio of two numbers. I'm going to do one of those things where it goes black and then it comes back again while I wipe down the board, and we'll do the next one. See you in a minute. Right, for the next one, G minus H. Okay, G minus H is equal to 3 plus root 5, that's my G, minus 3 minus root 5, that's my H. Now the rational and irrational bit in these is concerning the square roots. The square root of 5 is an irrational number. 3's fine, but anything with root 5's in is going to be irrational. So let's just simplify that and let's see where we get to. Hopefully you might have spotted these negatives and not get confused by them. We've got all in all a 3, take away another 3, plus a root 5, and watch this one here, take away a negative root 5. Okay, those two do not cancel out. So if you had a root 5, take away a root 5 and got nothing out of that, it was wrong. 3 take away 3, they cancel out, and what we get on here, take away a negative root 5 is the same as add a root 5. That comes down to 2 root 5, which is irrational. Okay, so the first one is irrational. What about the second one? Let's go for green. H squared. H squared, that is 3 minus root 5 times by 3 minus root 5. Okay, here's where we're going to use our FOIL or our dragon clause, multiplying out a quadratic. The first two, we've got 3 squared. The outside two, we've got negative 3 root 5, or you could write that as take away 3 root 5, both of those fine. The inside two, we've got another minus 3 root 5, and the last two, we've got a negative root 5 times a negative root 5, which is actually a positive root 5 squared. Okay? And there's your dragon clause with your little drops of blood. It's green blood. Dragons have green blood. You did know that, didn't you? Okay, simplifying this, 3 squared is 9. And we've got this here, we've got root 5 squared. Well, root 5 squared is 5. So that actually becomes a rational number. The square of a square root is rational. And here we've got take away 3 root 5, take away another 3 root 5, so that gives us take away 6 root 5. Okay, so that's 14 minus 6 root 5. Irrational! Okay, going to wipe down the board again and I'll do the last one. See you in a minute. Right, the last one, GH. So GH is equal to 3 plus root 5 multiplied by 3 minus root 5. You may possibly spot this as a standard result. The last one, by the way, was a perfect square. This is something different, but just in case you don't, we'll work through it. Again, we're going to use quadratic multiplying out, FOIL or dragon clause. So the first two, we've got 3 times 3. The outside two, we've got minus 3 root 5. The inside two, we've got plus 3 root 5. Aha! And for the last two, we've got a plus root 5 times a negative root 5, which is a minus root 5 squared. Ah! 3 squared, that's 9, minus root 5 squared. Root 5 squared is 5, so that's minus 5. And then we've got a minus 3 root 5 plus 3 root 5. They cancel out, and the answer is 4. Rational. Ta-da! Hopefully you might recognise this one as a difference of 2 squares. That is 3 squared. There's your difference. And that is root 5 squared, because we had that there. So that squared and that squared. Difference of 2 squares. Standard result. Hopefully you spotted that. Right, that's enough for these. Bit more on Surds in some other questions, rational and irrational other ones. I will see you next time in another video. Bye for now, Batty fans.